this video, we're going to do another calculus optimization problem. We're going to start off talking about an oil well that is 2 miles offshore and 4 miles up the coast from the refinery. The cost to lay pipe offshore is twice the cost to lay the pipe onshore. So we want to find out what is the most economical route for the pipe from the well to the refinery. So we probably want to draw a picture. So we know this distance, and then down here is the shore. Okay, so we'll draw a shoreline here. So we're going to say that this distance is x. Okay, and then this distance is 4 minus x. So then this distance, using the Pythagorean theorem, is going to be x squared plus 4. Okay, so this is a right triangle. Now, so our cost function, and we'll call this c of x. So our cost function is 2. So 2 times the square root of x squared plus 4. Remember, the cost is twice as much. Plus, we have the cost of the onshore pipe laying, which is going to be 1 times 4 minus x. Okay, so the x squared plus 4 is the distance that we're going to travel underwater, and the 4 minus x is going to be the piping onshore. Okay, so in order to optimize this, we of course have to take the derivative. So c prime of x, I guess first before we do that, let's put that in a little bit friendlier form. So we're going to say that's 2 times x squared plus 4, the 1/2, and we can of course drop the 1 times 4 minus x, because that's just going to be 4 minus x. Okay, so let's take the derivative. So c prime of x then is going to be 2 times 1/2, we're bringing down the power 1/2, times x squared plus 4 to the negative 1/2. Okay, then the derivative of the inside, of course, is going to be 2x. And then the derivative of 4 is 0, and the derivative of negative x is going to be negative 1. So let's clean this up a little bit. So we've got 2x then over the square root of x squared plus 4 minus 1, and we're going to set that equal to 0. So now let's add 1 to both sides. So we're going to have 1 equals 2x over the square root of x squared plus 4. So we're going to multiply both sides by x squared plus 4. So we're going to get 2x equals x squared plus 4. And if we square both sides, we're going to get 4x squared on the left, and we're going to get x squared plus 4 on the right. So now let's subtract x squared from both sides. So we're going to have 3x squared equals 4. So let's divide both sides by 3. So we're going to have x squared equals 4/3. Okay. Take the square root of both sides. We're going to see that x is going to equal 2 over the square root of 3. And we can rationalize that denominator if you want to. So we can say that that's going to be 2 roots of 3 over 3. And that's what x is going to equal. Okay. So the amount of pipe that we're going to have to lay offshore. So we're going to put in here, so our cost, actually, let's talk about the distance of the pipe. So the distance of the pipe offshore is going to be the square root of 2 roots of 3 over 3 plus 4. And then, so this is the amount offshore. And then we have 4 minus 2 roots of 3 over 3. And that's going to be the amount that's going to be onshore. So that's going to be not the amount, pardon me, but that's going to be the distance that the pipe is going to travel onshore. So there are our distances optimized. So thank you for watching.